In this demonstration, we are going to see how to distribute a large language model across multiple GPU instances that are distributed across different virtual machines. For this demonstration, we have got two virtual machine instances running on EC2, and both of these instances are of type G5 2x large, and both these instances can communicate with each other through appropriate configurations of VPC, subnet, and security groups. Now let's go ahead and take a look at how do we go ahead and set up distributed inferencing across these two virtual machines. So first step would be to set up the rake cluster across these two virtual machine instances. And in order to set up the rake cluster, we can potentially use the run cluster shell script that's provided by the vLLM documentation. And I've gone ahead and used that specific script in order to set up the rake cluster across these two instances. And as you can see from the logs, this virtual machine instance is nominated as the head node, and we have the rake cluster running here. And if I switch back to the other virtual machine, we can also see that the rake cluster is running in this instance as well. And this is being configured as the worker node. Now, let's go ahead and take a look at the status of the rake cluster in this machine. So in order to do that, I'm going to log into one of the containers where the vLLM is running as part of the rake cluster. So, and within this container, let's check the status of the rake cluster. And we can see that the cluster has been formed successfully, and we can see both the nodes visible in this cluster. And before we go ahead and use this cluster for doing the distributed inferencing, let's take a look at the GPU availability across these two virtual machine instances. And for that, let's use the standard NVIDIA SMI command to see the GPU availability in this virtual machine. We can see that we have got 1A10G, and similarly on the other instance as well, we should be able to see a similar GPU instance available here as well, right? Now, let's leverage these two instances of GPUs and distribute one of the large language models across both these GPU instances for our inferencing purposes, right? So in order to do that, let's once again go back to the container, start the vLLM instance, use this for serving purpose. And for this demonstration, let's keep the tensor parallel size as 1, and we will use the pipeline parallelism using which the LLM would get distributed across these two GPUs. So let's start the vLLM serve here, and this should get started in a few minutes. We can see that it's connected to the cluster, which means it is able to identify both the nodes, and it's able to distribute the large language model across both these instances of GPUs. Okay, all right, so the vLLM server has started now, and it's available for serving. Now, let's test this setup to see how the distribution of large language model really happens. So in order to do that, let's utilize test script. So here is the current GPU utilization. As you can see in both these nodes, I mean, for the first node, we can see that it's right now 0%. And if I go to the second node here, you can also see that it is 0% right now, right? So let's simulate some load on this setup. In order to do that, I'm going to run a specific script for that, which is just going to make the chat completion API calls to the LLM instances. And let's take a look at that. If it's going through, yes, it has started invoking the vLLM API. And now if we go back to the GPU utilization on both these instances, we can see that this is instance 1, where we can see that it's 34% utilized. And if we go to the other instance, you can see that its utilization is around 39 to 45%, right? So this confirms that actually the GPU that's available across two different machines are actually being leveraged in order to serve the single large language model that we have got for this demonstration. I hope this helps to understand the fact that Ray cluster really helps us to distribute the large language model across two different GPUs that are available across two different virtual machine instances. Thank you.